Now we'll find out about how we feel that things hurt.
So, how is it?
Well, I've been sitting still for 4 hours.
We humans have gotten hurt, been in pain, and suffered since time immemorial. But to this day, we still don't really know how pain works in our bodies. So to map the pathways of pain inside us, and to help cure everything from chronic pain to headaches, Håkan Olausson's team is measuring different pain impulses. And Håkan is fascinated with pain as a phenomenon, even though Håkan himself is not very fond of pain.
I strongly dislike pain, and if I go to the dentist, I want to have as much anesthesia as possible. So I think I'm like everyone else, with regard to my own pain.
But the fact that pain pathways in the body are so unknown, that's exciting.
My feeling is that we are only in the beginning of understanding how pain is processed.
From the beginning, Håkan actually studied something more pleasant, namely caresses, in Canada. And there he became one of the first researchers to discover the nerve cells for light touch. They could see that gentle touches activated special neurons that sent signals through their own nerve fibers to the brain. This was a groundbreaking discovery, a new signaling system in the human body. Previously, the known nerve fibers were only those for normal touch and signals from pain neurons. But the pain signals known at the time were quite slow, until Håkan's team found something completely new, a bit by chance. Håkan had just moved his research to Linköping and was testing the microneurography equipment, which is still used here today. This is a Swedish invention from the 60s, where a thin needle is inserted into a single nerve cell to measure the nerve signal and transform it into sound waves and data.
First wanted to do something rather simple, so we just thought we should record from touch fibers. And so when we were recording from touch fibers, we found a nerve cell that required sharp indentation, painful sharp indentation to respond. And by chance, we thought it would be fun to measure the conduction velocity of that nerve cell. And we found that the conduction velocity in that particular nerve cell was as fast as the conduction velocity in touch fibers. And every textbook will say that touch is signaled much faster than pain. But we found pain fibers that were as fast as touch fibers.
Håkan was now involved in his second completely groundbreaking discovery. As the research continued, they found that these new pain fibers were everywhere in the body, and the signals traveled faster than anyone could have imagined. Whereas the previously known pain signals moved at 1 meter per second, these traveled at 40 meters per second. But this time, Håkan himself was the leading researcher, together with his postdoc, Saad Nagy. They toasted with champagne, of course.
I think we had champagne. I hope we had champagne.
But the celebration itself was far from the most fun.
The most exciting things is when you find something new and you see the data, when the data is coming in. Start to get more and more recordings from a similar nerve cell and start to see the data building up. And that, I think, is very exciting.
The discovery of the ultra-fast pain system means that Håkan's team is looking for pain signals in a new way. Like here, when a larger needle is pushed up under the foot with variable force.
It's okay. This reflex is multisegmental, so it actually goes up to the brain also. So it's different from, for instance, the patellar reflex that only goes through the spine and back. So this actually goes up to the brain as well.
So it's very fast. It's fast.
It's fast, yeah. Feels nice, or?
And a couple of floors above the lab, Bengt Ragnemalm is helping Håkan develop new machines for collecting new data.
This must be the only automatic hair puller in the world now.
No, it's the second one.
Yeah.
So this is moving up and down.
Yeah, and
mean,
pulls the hair
yeah.
until it's painful.
Yes, exactly.
Fantastic.
The high position and also what speed we,
But yeah,
we
what
want.
speed can you get? Really high speed?
High speed. To super slow.
It seems like the nerve cells signaling hair pull are ultra fast. So that's a second class of ultra fast nociceptors.
Very
And all these tests to map previously unknown pain signaling systems, Håkan hopes will one day lead to better methods for diagnosing pain patients, and that this knowledge will help other researchers develop more effective treatments for chronic pain.
I hope our research can lead to better care of chronic pain patients. So that's our ultimate goal, better care of chronic pain patients.
And today's test subject Tilda Johnson is looking forward to moving after sitting completely still for 5 hours for science.
I'm gonna go home and then I'm gonna just run because I don't have to sit still anymore.